Mesh analysis. So let's go through the main step of mesh analysis on the following example. First of all, what is mesh analysis or current mesh method? Mesh analysis is the application of the Kirchhoff's voltage law or KVL, which states that the sum of all voltages in the closed loop equals to 0. But now the question is, what is mesh? What is actually mesh? Mesh is the single closed loop which do not consist any more loops inside. As we can see on our diagram, we have two single loops. This is one loop and the second loop. So that means that there is only two meshes, and we can call them as mesh 1 and mesh 2. But applying KVL to each mesh, we also need to consider a voltage polarity. So how does it work? The voltage encountered from plus to minus is assigned as positive, and voltage encountered from minus to plus is assigned as negative. So what does it mean? Let's say you select the single element, and if you follow by the direction of the current, and the current flows from plus to minus, the voltage is assigned as positive. So let's say plus V. And the other way around, if the current flows from minus to plus, the voltage will be assigned as negative V. Now we are ready to start the first step of solving the problem, and step 1 is to assign mesh currents to n meshes. Because we have two meshes, we need to assign two mesh currents. Like shown on the diagram, I1 will be the mesh current for mesh 1, and I2 will assign as the mesh current for mesh 2. To make it easier and consistent, let's assume that mesh currents will flow always clockwise in the loop, in the mesh. It really doesn't matter, so the mesh current could be going counterclockwise or anti-clockwise as well, but just make it easier just to remember, so assume that mesh currents always will be flowing in clockwise direction. So that means if you look on the current direction in each branch for mesh 1 and mesh 2, let's see where the current will flow. So in first mesh, again going clockwise in the loop, so here will be the direction of the current, and in the second loop, again the arrows point in the direction of the current in each branch around the loop. The second step is to apply KVL to each mesh. Because the KVL is the sum of all voltages, we need to find the voltage across each resistor, across each element. So we'll be using the Ohm's law, which states that voltage equals V equals IR, current times resistance. So let's start straight with the equation. So for mesh 1, and I'll start with the 2 ohms resistor. So because we'll be using the mesh current I1, so assume that the positive direction of the current, and so the voltage in 2 ohm resistor will be assigned as positive and could be found as 2 I1. So this is the voltage in 2 ohm resistor. Then we go into 12 ohm resistor. So we can say, and in 12 ohm resistor we have a different situation, because if you can see, there are actually two currents flowing through 12 ohm resistor. One mesh current is I1, and the second mesh current is I2. Because we don't know what would be the resultant current at this stage, so let's assume that the current in this branch will be called I3. So the voltage across 12 ohm resistor will be plus 12 I3. Then we move into 4 ohms resistor, and again this is positive, plus 4, and the only current flows through 4 ohm resistor is I1, so 4I I1, and then we're going to the voltage source, 36 volts, and going in a clockwise direction. We're going from minus to plus, so we're going this way from minus to plus. That means that the voltage will be assigned as negative, and we need to put negative minus 36 to the equation, and this is all the elements in the single loop. So we can say that everything is equals to 0. Now let's repeat the procedure for mesh 2. So let's start with 9 ohms resistor. The voltage across 9 ohms resistor will be assigned as positive, and there is only I2 current flowing through that resistor, so we can write 9 I2. Then going through 24 volts, we're going from plus to minus, so the voltage is assigned as positive, so we put plus 24. 3 ohms also positive, plus 3 I2. And now we're going to 12 ohms resistor, and because we decided that current I3 is going downwards, which is opposite to I2, we assign this voltage as negative, so we put minus 12 I3. And we have 4 elements in the loop, we have 4 components in the equation, so everything is, we can say it is equals to 0. But now the interesting question. First of all, we just wrote 2 equations, but if you look on this, we have more than 2 unknowns. We don't know what is mesh current I1, we don't know mesh current I2, and we also don't know the mesh current I3. So what do we need to do? We need to substitute mesh current I3 by express it via I1 and I2. How to do this? If you look into the upper node, and I just write it closer, so this is the node, and we have the mesh current I1 coming into the node, the mesh current I2 going out from the node, so this is I2, and I3 again going out. If we apply KCL for this node, we will see that I1 equals to I3 plus I2, or we can express I3 as I1 minus I2. Why do we need this? Because we now can rewrite our equations by substituting current I3 as the difference I1 minus I2. Let's see what we'll get. And again, start with 2 ohms. We have 2 I1. Then instead of writing 12 I3, we can write plus 12 I1 minus 12 I2. Then going to 4 ohms resistor, it will be plus 4 I1 and minus 36 equals to 0. Then the same thing for mesh 2, and starting with 9 ohms, we need to write 9 I2, then plus 24, then plus 3 I2, and because we're going against current I3, basically we can flip it. We can negative I3, because this is what we're supposed to do, will be, I just write it here, negative I3 equals to I2 minus I1. So we can say that the next component will be positive plus 12 I2 and minus 12 I1. Now we created two mesh equations. One equation for mesh 2 and another equation for mesh 1. And the last step is to solve the resultant n equations. In our case, this is only two equations, to find I1 and I2. So this is just two equations we created in the previous step. They're simplified. So let's solve them. What we can do? So let's just multiply the first equation by 2. And what we're going to have? 36 I1 minus 24 I2 equals 72. Then we'll add the first equation to the second equation. So this is the equation we'll got, and we can see that minus 24 I2 and plus 24 I2 are cancelled out, and at the end we'll get 36 minus 12 is 24 I1 equals to 72 minus 24, 48, and I1 is 48 over 24, 2 amps. If we already know I1, we can substitute this to the first or to the second equation and easily find I2. For example, I can sub it into the second equation, and that gives us that I2 will be 12 times I1, so 12 times 2 minus 24 over 24, which actually gives us the current I2 equals to 0. So this is two answers. We found two mesh currents. I1 is 2 amp and I2 is 0 amps.